Hello, this is Professor Kuehn. Welcome back to my lectures on space, time, and motion, where we have been looking at Newton's Principia. This is the final lecture on the Principia, and in this lecture I'm going to be looking at chapter 28 in A Student's Guide to the Great Physics text. This chapter is titled Hypothesis and Natural Theology. It's a bit of a different kind of chapter, and it's drawn from the end of Book 3 of Newton's Principia. So this is kind of his final ruminations or thoughts on the mathematical theory of gravity that he has developed. And so what I'd like to do is I'd like to step through this and kind of highlight some of the points that Newton is making. Remember the gist of what he's done so far is he's developed his laws of motion, Newton's 3 laws of motion. He showed how to apply these laws of motion, and then he's applied them specifically to the case of planetary motion, and he developed his universal law of gravitation. Okay, so let's jump right into this. If we look at page 322, Newton begins by saying that, and remember this is one of his General Scholia. He says, the hypothesis of vortices is pressed with many difficulties. What is he talking about here? Well, one of the theories at the time that was in competition with Newton's theory of gravity was Descartes' theory of planetary motion. He wrote about it in a book called The World, which was written in about the 1630s. Remember, Newton wrote his Principia in 1687, so Descartes did his writing a bit earlier. I think it was published in the 1660s finally, Descartes' work was. But in his book called The World, what Descartes essentially argued was that the planets are orbiting around the sun, so he was in agreement with Copernicus, like Newton was. The planets are orbiting around the sun, but not because of a gravitational force of attraction to the sun, as Newton would argue, but rather because space is filled with this ethereal matter that's kind of like a fluid, and it's swirling around in vortices around the sun. So think about if you take a bath, if you open the plug in the bathtub, the water begins to spiral around the drain, and if you were to float a rubber ducky in your tub, it would swirl around the drain. Well, that's the kind of view that Descartes had for why the planets were moving the way they did. He imagined that this ethereal medium was swirling around the sun, and the planets were being dragged around kind of like rubber duckies around this whirlpool. Newton now is really putting a shot across the bow here. He's saying this hypothesis of vortices of Descartes, without mentioning Descartes by name, is pressed with many difficulties. It doesn't work. What are some of the specific difficulties that Newton mentions about this? Well, first of all, the numbers don't work out quite right. If you were to look at the way that vortices work, that is how fluids swirl around a drain, if you were to place 2 rubber duckies or leaves floating on the surface of the water, and you were to measure the time that they took to go around the drain, the periodic times would not go as the radius to the 3/2 power. That is, they don't obey Kepler's law of planetary motion. There are some other problems that he brings up in this first paragraph having to do with things like the fact that Saturn has moons that are orbiting around Saturn. And in order for the moons of Saturn to not be disturbed as they're orbiting around Saturn, obeying Kepler's laws of planetary motion, one would need to have a vortex swirling around the sun that doesn't in any way interact with this vortex. It doesn't mess up the motion of Saturn's moons, which is very difficult to conceive of something like that. And another problem that he brings up at the end of this paragraph is how the comets follow very eccentric orbits that would have to intersect the other planets. So you might think about it this way, if I draw a picture. If you've got the sun right here, and you've got these planets like Mercury and Venus and Earth and Mars and so on going around the sun, they are obeying Kepler's laws of planetary motion, but then you've got these comets that had been recently being looked at that have very eccentric orbits around the sun. And if you are going to say that vortices can account for both the planetary motion and the comet motion, you would need to have these intersecting vortices. And that doesn't seem to be quite feasible. Those are some of the difficulties that Newton brings up in this first paragraph. I don't want to dwell on this for too much time, but we'll leave it at that. Okay? Another thing that he mentions is that if we jump ahead to the second paragraph, he says, bodies projected in our air suffer no resistance from the air. And he's going to specifically talk about the recent experiments of Mr. Boyle. Mr. Boyle had developed a vacuum chamber and was dropping objects in a vacuum chamber and showing that in the absence of air resistance, a lead ball and a feather fall with the exact same acceleration. And then what Newton does is he goes on to talk about how in outer space, the planets are able to move through outer space similarly as an object moving in with no air resistance. That is, space is a vacuum. And he says here that, I'll just go ahead and read this, the planets and comets will constantly pursue the revolutions in orbits given in kind and position according to the laws above explained. That is, the planets and the comets obey the universal law of gravitation. But, he goes on to say, though these bodies may indeed preserve in their orbits by the mere law of gravity, yet they could by no means have at first derived the regular positions of the orbits themselves from those laws. So notice what he's doing here. He's saying that his universal law of gravity can account for the motion of the planets provided they have an initial velocity. So if you have Mars that was given an initial velocity around the sun, the universal law of gravity will account for the continued orbiting of Mars around the sun, but it can't account for the initial velocity of Mars. And likewise with the other planets. The laws of gravity, or the law of gravity, can continue things moving in the way that they already are, but they can't account for the origin of things. And that's what he goes on to talk about in the following paragraph. He says the 6 primary planets are revolved about the sun in circles, concentric or roughly concentric, with the sun, and with motions directed toward the same parts. That is, they're all feeling a centripetal force toward the same location, that is, toward the sun. And they all lie almost in the same plane. 10 moons are revolved about the Earth, Jupiter, and Saturn. He's talking about the cumulative moons of Earth, Jupiter, and Saturn, in circles concentric with them, with the same direction of motion. That's important. All the planets and all the moons are going in the same direction or the same orientation of their motion, and nearly in the planes of the orbits of those planets. But it is not to be conceived, and this is the important point that he's making, it is not to be conceived that mere mechanical causes could give birth to so many regular motions, since the comets range over all parts of the heavens in very eccentric orbits. For by that kind of motion they pass easily through the orbs of the planets, and with great rapidity, and in their aphelions, where they move the slowest, and are detained the longest, they recede to the greatest distances from each other, and thence suffer the least disturbance from their mutual attractions. So what he's getting at here is the comets, the moons of Jupiter, Saturn, Earth, and the planets that orbit the sun all obey the universal law of gravitation, as he argued in the last chapter. But this coincidence of the way that things are all moving, it cannot be accounted for by mere mechanical causes. And by mechanical causes, he's thinking about things like the push or pull of one body pushing or pulling on another, or the law of gravity that's pulling all of the planets together. He says, this most beautiful system of the sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being. So what is he doing here? He's saying that the orderliness of the universe needs, as an explanation, an intelligent and powerful being. This is how Newton argues for the existence of God. This is a kind of a classic argument from design. One cannot account for the way things look in the universe without appealing to a God. He says, if the fixed stars are the centers of other like systems, these being formed by the like wise counsel must be all subject to the dominion of one, especially since the light of the fixed stars is of the same nature with the light of the sun, and from every system light passes into all the other systems, unless the systems of the fixed stars should, by their gravity, fall on each other mutually, he hath placed those systems at immense distances from one another. So what is he saying here? He's saying the stars are like the sun. They produce light. And also, like the sun, they have gravitational attraction. So why do the stars not all attract each other and fall into one big clump in the middle of the universe? This is an important problem. And he's saying there had to be an intelligent agent that placed them in such a way that they do not do that. How did he do that? He placed them far enough away from each other so that the attraction is weak enough that they do not fall into each other. Of course, given enough time, they would, and this would imply that the universe was created not so long ago. That is, not long enough for them to have collapsed back into a single pile in the middle of the universe. Now, what does Newton do next? The next couple of paragraphs are very interesting because here is where he gets into what is typically called natural theology. That is, what one can say about God based on looking at nature. He says, to begin this paragraph, he says, this being, God, governs all things not as the soul of the world, but as Lord over all. So he's saying there's a distinction between God and the world. This is different than some older views or some ancient views that identified God with the world itself, or said that in some way God was identical with the world. He's saying, no, God is outside of the world, but he's Lord and he has dominion over the world. I don't have time to get into all of the arguments that he presents in this chapter, and partially the difficulty of this next paragraph, the difficulty of this next paragraph is that it draws on a lot of classic arguments that had been articulated over the past several centuries about the nature of God. And to get into this, one would really need to have a deeper understanding of medieval and scholastic philosophy that Newton here is drawing upon quite heavily. Let me just point out a couple of things that I found particularly interesting. He mentions that God has these properties of eternity. He's eternal, he's omnipotent, he's omnipresent, that is present everywhere, and omniscient, and that he is simple or one. And whereas the universe or the world around us changes, God himself is unchanging. And these you might think are strictly theological claims based on the Bible, perhaps, but these are classic arguments based on reason, and that's the important thing that he is pointing out here. One can rationally deduce these kinds of things about God by looking at nature. Even though he doesn't go into the proofs here, he's kind of ticking off these things that were accepted scholastic philosophy. So I'm just going to skip over this paragraph, but I encourage you to take a look at it. You may be uncomfortable with this kind of thing, the idea of deriving properties of God by looking at nature. But this is something that was very common at this time period, but there's a certain level of skepticism that people come at this with in the modern period that I believe is unwarranted. In any case, let's jump to the next page, page 324. The bottom of page 324 is where he talks about how gravity is a property that is cumulative. So he says, hitherto we have explained the phenomena of the heavens and our sea by the power of gravity, but have not yet assigned the cause of this power. So he's saying we can sit here and talk about that there must be a gravitational force and what the mathematical structure of this gravitational force is, but we don't really understand why it's there or what's the cause of it. And he points out a couple of things in this paragraph, that it is not a surface effect, rather it is a bulk effect. What does he mean by that? He means that the gravitational force is not blocked. So if you have a piece of material deep inside of the Earth, it, just like the pieces of material on the surface of the Earth, it is able to pull on the moon. So the outer particles of the Earth do not in some way block the gravitational force that the inner particles of the Earth exert on the moon. So it depends on the mass and hence the volume of the Earth, not the surface of the Earth. So this is something that he points out at the end of this page 324. If we jump ahead to page 325, he says, it is enough to us that gravity does really exist and act according to the laws which we have explained, and abundantly serves to account for all the motions of the celestial bodies and of our seas. And then, finally, he ends his Principia by broaching the subject of what it is that causes man or people, or more generally living things, to act in the way that they do. He says, and now we might add something concerning a certain most subtle spirit which pervades and lies hid in all gross or tangible bodies, by the force and action of which spirit the particles of bodies mutually attract one another at near distances and cohere if contiguous. and electric bodies operate to greater distances, as well repelling as attracting the neighboring corpuscles, or objects out of which they're built. And light is emitted, reflected, refracted, inflected, and heats bodies, and all sensation is excited, and the members of animal bodies have at the command of the will, namely by the vibrations of this spirit, mutually propagated along the solid filaments of the nerves, from our outward organs of sense to the brain, and from the brain into the muscles. But these are things that cannot be explained in a few words, nor are we furnished with that sufficiency of experiments which is required to an accurate determination and demonstration of the laws by which this electric and elastic spirit operates. So here, people had been doing some experiments on electricity and how electricity can account for the cohesion of objects. This is something that Newton, as an alchemist, was very interested in. And here he is suggesting that perhaps these electrical forces can account for the action of the mind and the brain, and he calls it this spirit in order to move the limbs. And so he's really bringing up a lot of very interesting topics here, and we are going to have to put Newton aside, though, and move on to the topic of relativity.